So now we're going to move on to how we do some calculations using what we know about acids. And we're going to start with the basic calculations. And this is going to be the foundation for everything we do with acids and bases in this unit. So you want to make sure that you're comfortable with what we're doing. We're going to look at what's called the ionization of water. Conductivity experiments have shown that water ionizes according to the equation. And this may look weird. Water plus water equals our hydronium ion plus our hydroxide. And if we think about it, this is a liquid, and this is a liquid, and these would both be aqueous. It's a funny way to think of water, but it's going to really be the basis of everything we do in acids and bases. And so if we were to write an equilibrium expression, we know that equilibrium expressions are products over reactants, concentrations of products over concentrations of reactants, but our reactants in this case are liquids, and so they're not included in our equilibrium expression. So we're going to have a special equilibrium expression. We've learned about KSP, we've learned about KEQ, we're going to call this one KW, KW for water. And so we're going to have the concentration of H3O and the concentration of OH minus. A lot of times you'll see this H3O plus also just written as H plus. Remember, they're interchangeable, and you just have to accept that through this unit because you'll see it both ways. It ionizes according to this idea that in perfectly neutral water, we have 1 times 10 to the negative 7th is the concentration of H3O plus, and 1 times 10 to the negative 7th is the concentration of hydroxide, meaning that KW, and this is a constant, and you'll just have to know this, but it won't be hard because we're going to use it so much, is 1.0 times 10 to the negative 14th. So how do we use this information? Well, we have some problems. So what if we want to find the hydroxide in a water solution that has a hydrogen ion concentration of 1 times 10 to the negative 5th? Obviously, there'd be some sort of hydrogen ion that had been added to it. So we're going to use our equation. KW is equal to H plus, and it could be H3O plus. That would be fine. We know KW is 1 times 10 to the negative 14th. That doesn't limit any significant figures because it's a constant. I should be writing probably 1.0 there. I'm going to fill in the 1.00 times 10 to the minus 5, and then I'm going to solve for hydroxide. And all I'm going to do is I'm going to divide the 1 times 10 to the negative 14th by 1 times 10 to the negative 5th. And if you know your rules of exponents, you just know that you're subtracting that. And so hydroxide, that's not a very good bracket there, is equal to 1.00 times 10 to the negative 9th. And that's a molarity. Let's try another one. What's the hydronium ion concentration? That's the H plus. In a solution with a hydroxide ion concentration of 6.0 times 10 to the negative 10th. Oops, so sorry. Oops. KW is equal to H plus times OH minus 1 times 10 to the minus 14 is equal to H plus, which is what we're looking for, times 6.80 times 10 to the minus 10, and so H plus is equal to 1.47 times 10 to the minus 5. Make sure that you can punch all of that into your calculator. So then we're going to move on to what's referred to as the pH scale. And pH, we're going to learn to do some calculations with pH. But you got a taste of that with doing the lab. 7 is considered to be perfectly neutral. These are our neutral compounds. Things that have a pH that are less than 7 are considered to be acidic. The further you are from 7, the more acidic you are. If we look, anything larger than 7 is considered to be alkaline. Alkaline, another word for alkaline, is basic. So we could say weakly basic and strongly basic, but alkaline is another term that you'll hear fairly common, acidic and alkaline. These are just some, interesting charts to put up. I like this one because it talks about the environmental effects. So in environmental science, we'll take a look at how these different pHs start to affect different organisms. But if you can look, battery acid, sulfuric acid, lemon juice, orange juice, soda, these are all things, common things that we tested. Acid rain in an acidic lake, bananas, clean rain, which is a little bit acidic. A healthy lake is about 6.5. Milk, pure water. And then we have seawater, eggs, baking soda, we go milk and magnesia, ammonia, soapy water, bleach, and then liquid drain cleaner. Very, very, very basic. And I also like this one. It just has a visual effect of the same sort of information as to where it fits. But you can think of the things that we ingest, the citrusy type things are acidic, and then cleaning things tend to fall into that basic category. So the pH scale is really a measure of the hydronium ion concentration. And P, this operator, which has to be lowercase, you don't write pH with a capital P and an H, this P means the negative log of. So here's our definition. pH is the negative log of the H3O plus, or pH is the negative log of H plus, since we know those are interchangeable. Okay, so that's what the P is an operator, and that's what it stands for. So if we're going to try this, we're going to find the pH of 1.0 times 10 to the negative 3. Now, log is a base 10 scale, and so it's very easy to do problems that are 1 times 10 to a certain number. But pH is equal to the negative log of 1.00 times 10 to the minus 3. And absolutely, if you have or haven't worked with logs, please make sure you can do this in your calculator. But you plug that in, you press your log button, actually you press your negative, then your log button, and then type in this number in parentheses, and you should end up with the answer of 3. It's easy when it's 1 times 10 to a number. This one we can't do by sight without our calculator. So this one we have to plug into a calculator. pH is equal to the negative log of 6.59 times 10 to the minus 10. We plug that in and go ahead and try that. And you should end up with 9.18. And then we can go this way and work backwards to find the hydronium ion concentration. So if we're given the pH, we need to work backwards to figure out what the hydrogen ion concentration is. So we're still going to use our equation. pH is equal to the negative log of the H plus. Only this time I'm going to fill in 3.0 is equal to the negative log of H plus. And I'm really working through every last detail here so you can see how it works. I'm going to bring my negative to the other side. Negative 3.0 is equal to the log of H plus. Now a lot of people get stuck here and they don't know what to do on their calculator. What you're going to type is your second plus the log button. It might be shift on your calculator. So this is what you're typing in. And what should come up on your screen is 10 caret parentheses. And then you're going to type in negative 3.0. Once you type that in, you should end up with 1.0 times 10 to the minus 3. Again, this is a base 10, so it's easy. This 3 is just becoming this 3, negative. So if you know that fact, you don't have to do any calculations. But I wanted you to see how it goes into the calculator. If pH is equal to 10, look, we don't have to do any calculations. Just like with pH equal to 3 with a whole number, pH equal to 10, we know our answer is just going to be 1.0 times 10 to the minus 10. However, if we have something like pH is equal to 6.6, well, there's no way around it. We do have to use our calculator. So, again, I'm going to put that there. What we have is 6.6 is equal to the negative log of H plus. We have negative 6.6 is equal to the log of H plus. We have to get that negative on the other side before we hit our shift. You're going to press that second log again on your calculator, and it should look like this, 10 caret parenthesis, and then you're going to type in negative 6.6, and your answer should end up being 2.57 times 10 to the minus 7. We have another relationship between pH and pOH. pOH is the negative log of the hydroxide ion. So this here is the negative log of the OH minus ion. So we can use it the exact same way we use pH, but pH plus pOH is 14. So to find the pH, if we have a pOH of 2, we're just going to use that relationship of pH plus pOH is equal to 14. pH plus 2 equals 14, and it's easy to see that we just subtract our pH is equal to 12. If our pOH is equal to 11.2, same thing, we're going to do 14 minus 11.2, and we'll get a pH of 2.8. Now we're going to do sort of a double-step problem. Determine the pH of the solution for the following hydroxide ion concentration. So we have a hydroxide ion concentration of 1 times 10 to the minus 4. Well, I need to find, if I'm going to find the pH, I need the hydrogen ion concentration. And so I'm going to do Kw is equal to H plus times OH minus. I'm going to have 1 times 10 to the minus 14 is equal to H plus times 1 times 10 to the minus 4. I know, because I can do minus 14 and subtract that 4, that I'm going to get an H plus that's equal to 1.0 times 10 to the minus 10. And that's easy to do my pH, because if I know the hydrogen ion concentration, it's this perfect answer like this, I know it's going to be 10. However, if I have a number like 3.45 times 10 to the minus 8, I have to use my calculator. There's no way around it. I'm going to do the same steps that I did up there. 1 times 10 to the minus 14 is equal to H plus times 3.45 times 10 to the negative 8. I'm going to get a hydrogen ion concentration equal to 2.90 times 10 to the minus 7. I'm going to do pH is equal to the negative log of 2.90 times 10 to the minus 7. I'm going to go ahead and type that into my calculator, and my pH ends up being 6.538. Okay, no, none of these constants limit my significant figures. Okay, and when you use logs, this number isn't considered significant. This number is. So you always want to have 2 or 3 numbers after the decimal. And then finally here we have a chart for you to fill in. This will test if you really understand all of these relationships. You're going to use this 1 times 10 to the minus 14 is equal to H plus times OH minus. You're going to use pH is equal to the negative log of H plus, and you're going to use pH plus pOH equals 14. And you can solve it any way you want to fill in the blanks. You need to pause your video now, see if you can complete it, and then check to see that you did it correctly. Okay, here's the answers. Check your answers, make sure you did them correctly, and if you have any problems or have any questions, make sure you ask me in class so we can be sure to figure out what your problem is.